Welcome to lab number 1 of CE371. This short video will provide an overview of the laboratory procedures. I encourage you to follow along on the written procedures provided in your laboratory manual. During the video, additional detail will be provided beyond the content contained in your laboratory manual. Remember, there will be a quiz regarding these procedures at the start of the lab period. The first lab is the physical properties of soil. The lab procedure instructions outlined here will allow for the determination of the physical properties of a soil sample. Special attention should be given to the data collection sheets, as they will assist in ensuring that all necessary data is collected during the lab session. The lab is provided into 3 parts: the unit weight and moisture content determination, the visual analysis portion, and the determination of the specific unit weight of the soil solids. The unit weight determination. Step 1, weigh the full mold without the top collar. This is the mold. It's full of soil when you receive it. You want to loosen the top wing nuts and remove the top collar. We can place the top collar aside and we will not use it throughout the remainder of the lab. Using the large scale, we want to place the entire mold full of soil on the scale and record that on our data sheets. Step 2 is to empty the mold into the large pan. So at this point, we want to loosen the lower wing nuts. Should be able to pull the main portion of the mold and the soil sample off to the side. We want to make sure that when we remove the base, that we use a brush or something to get all the soil off the mold and into the pan. Place the base off to the side and loosen the wing nuts on the side of the mold enough to allow the mold to slide up and over the soil sample, making sure the entire soil sample ends up in the pan. And then again, use a brush to brush out the inside of the mold, making sure all that soil gets out of the mold and into the pan. Take your time in this step to make sure the mold is entirely clean. So after the soil has been removed from the mold is cleaned off, we're going to reassemble the base and the center portion of the mold. Again, leave the top collar off. And we're going to now at this point weigh the empty mold. Again, on the large scale. The difference between that first measurement and this new measurement is going to be simply the weight of the soil that was inside the mold. We know that the total volume of the mold is 1/30th of a cubic foot. Knowing the total weight of the soil and the total volume of the mold, at this point we can calculate the total or moist unit weight of the soil. The next step is a moisture content determination. To do so, we're going to utilize what's referred to as tear cans. We'll use tear cans throughout the entire semester. These are moisture content cans. They have a lid with them. Typically the base and the lid are numbered to go together. You want to make sure you keep those connected. We want to weigh both of these on the small scale, one at a time, with the lid. Typically just take the lid off the top, place it on the bottom, place it on the small scale, and make sure you record that number. Again, doing each of those individually, make sure you record that empty weight associated with the number on the can. And again, the number on the can and the number on the lid should match up. You want to place 2 to 3 teaspoons. So in your items at your lab station, you have a teaspoon here. You want to place 2 to 3 spoonfuls of soil, roughly 25 to 50 grams of soil in each tear can. This soil is going to be taken from the center of the soil sample that came out of the mold. If needed, you can use the tools at your station to break that up so that we can get towards the center of the mold. At the center of the soil that came out of the mold is where we get a representative sample as far as moisture content. So again, 2 to 3 good-sized teaspoons of soil going into each can, and ideally that soil coming from the center of the soil sample. Again, now you want to place those onto the small scale and record the new weight with the soil in there. Record those individually. Again, make sure you track based on the number on the can and the number on the lid. Once you've got a recorded weight, you want to make sure you get the lid placed on top of the tear can pretty quickly. We don't want to lose moisture from this process at this point. However, when you place these lids on top of the cans, please don't push them all the way down. We can leave them open a crack. And what we're going to do is we're going to take these cans, and the lab technician or the instructor is going to dictate where they should be placed in the lab. These will be placed in an oven for 24 hours, and the moisture will be removed in that process. We'll, at that point, reweigh the samples, and that information will be sent out to you via email. Again, make sure that you place the lid canted to the side. Don't want to push the lid all the way down, in which case it takes a lot longer for the moisture to evaporate from the soil. The next process is the visual analysis and soil description. In the 18 by 18 pan or the large pan at your station, what we want to do is we want to separate the gravel from the rest of the soil. So the gravel size soil would get retained or trapped on what's known as a number 4 sieve. At your station there will be a single sieve. It should be labeled as a number 4 on the side, and it should have openings that are roughly 1/4 inch to the naked eye. What we want to do is we want to break up our sample in the pan to begin with. To do so, you can use a variety of tools available to you at your station. This tool we affectionately call the eye poking tool. We use that frequently throughout the semester. Please don't poke your eyes with it. Break up the sample. That tool, you can use the bar with the sharp edge to go through and start to chop up the sample. As such. And another great tool is actually the round pan that's located at your station. Taking that and pushing down on the sample using the bottom of the pan will help to greatly break up the sample. This is not a step in the process that you want to hurry. You want to make sure you get this step done well. This will take easily 5 to 10 minutes of continuous work to make sure the sample is completely broken up. Once the sample is fully broken up, we're going to utilize that number 4 sieve. And the intent is to make sure that we're going to pass as much of the sample as possible through the number 4 sieve and separate out what passes through from what gets retained. So my recommendation is find a nice clear spot in your large pan, take the sample, and simply shake it. Do not try to force the sample through the number 4 sieve. If it gets caught on the number 4 sieve, it gets caught on the number 4 sieve, and that's important data to hold. We don't want to force anything through. In this process now, as we pass the entire sample through, we're placing the material that goes through the number 4 sieve off to the side, and the material that gets caught on the number 4 sieve, we're going to place in another section of the large pan at your table. Again, ultimately the goal here is to do a visual analysis of what percentage of this material passes through the number 4 sieve versus the percentage that gets caught on the number 4 sieve. Run your entire sample through there, make sure you get everything sorted out into those 2 different piles. Then you want to visually determine, as a percent of the total sample, how much of that is gravel. And again, the gravel is anything that gets caught on the number 4 sieve. You then want to complete the soil description using the data sheets, and you want to utilize table 4.2 in the DOS text to begin to classify the soil. You won't be able to do a full classification at this point, but you've got enough information to begin a classification of that soil. Again, make sure you completely fill in the data sheet associated with the visual soil description. The next step in this lab is a jar test, which is another rough field test to estimate percentages of materials. You're going to have an empty jar at your station with a lid on it. You want to take soil from the material, the pile that was sorted that went through the number 4 sieve, not the material that gets caught on the number 4 sieve. You want to take soil only from the area that went through the number 4 sieve, and we want to fill up your jar about 1/3 full with that material. Now the material that goes through the number 4 sieve is going to be the sand, silts, and or clay material. We don't know what it is at this point. I have some other pre-sorted material ready to go. And again, we're filling the jar to about 1/3 full. Not exact, you can shake it up a little bit to make sure it settles down. And then you're going to use a wax pen. Wax pen is provided at your table. Make sure the soil is level in the jar. And we're going to physically mark on the jar where the interface is right now between the top of the soil and the air above. We then want to use distilled water, again provided at your table, and we're going to fill up the jar up to what's known as the neck of the jar, so right where it starts to curve in at the top. We're going to fill that remainder of the space up with water, distilled water, which is going to leave some airspace between the top of the water now and the cap. Place the cap on nice and tight, and then shake this for a minimum of 30 seconds. Make sure somebody's timing that for you, and you want to continuously shake this sample up. What we're doing is we are suspending the small material in the water. After we've shaken for 30 seconds, I'm sorry, we're going to shake for an entire 60 seconds. Make sure that's corrected. That's an entire 60 seconds, 1 minute of shaking. Then you want to place the jar on the table and allow it to sit there for a minimum of 30 seconds. I've got a sample that was set aside here previously, and what this allows me to do now is look at the side of the sample. This has been sitting for over 30 seconds, and now I can take a look at and find on the jar, on the side of the jar, we should be able to visually see a separation between the sand particles and the fines. And again, the fines are the clay or the silt materials, but that will separate out by shaking, mechanically shaking that soil sample in the water. We're separating out the sand from the fines material. The theory is the sands are heavy particles and they will settle out of the water faster than the fines will. Another great way to get a handle on what type of soil we have in this jar would be to open the jar up at this point. This is an optional step in the process, but you can open the jar up and give it a good smell. And drink a little bit. If you're a really good geotechnical engineer, at this point in your education, you should be able to drink water with soil suspended in there and be able to determine what type of soil it is. Again, that's an optional step in the process. It's completely up to you if you'd like to try that. Our last process is the specific gravity of the soil solids. This is a two-step process. Part one is calibration of the flask. This is a volumetric flask. What we want to do is we want to, first of all, make sure that this is clean and empty. If it's not, take the time to go ahead and get it cleaned out and dry it. If there's water on the inside, we can use paper towel rolled up to make sure we go down in there and make sure the entire flask is dry before we start this process. We can use the small scale to weigh the empty flask. We're then going to fill the flask with de-aired, distilled water. I recommend you use a funnel for this process. And we're going to fill it up to the calibration line. The calibration line is a small white line that's located on the neck of the volumetric flask. For the large amount of the sample, we can start out simply by pouring through the flask, or through the funnel rather. Once we start to get up close to the neck, I recommend you slow down and use the squeeze bottle up until the point where we're just filling up to the calibration line. The idea is that the meniscus, the bottom of that curved surface on the water, should be just at that line. Take your time, make sure you get that properly filled. Realize that some water may be dripping out of the funnel in this process. Okay, remove the funnel. If there's any water, again, trapped on the neck, you want to make sure you use a roll-up paper towel to dry that out. We only want water in the flask up to the calibration line. At this point, we're going to reweigh the flask. The determine what the new weight of the flask with water in there is, and we want to record the temperature using the large thermometer that's provided. Make sure you're set into units of degrees Celsius. When we record the temperature at any of the steps where we're recording temperature, we're always going to record the temperature at the center of the ball in the flask. Using the known information on the temperature and this weight that we determined, we should at this point be able to determine what is the volume of the cylinder. The volume can be reported as either milliliters or cubic centimeters, but the number should be close to, but may not be exactly 500 milliliters or 500 cubic centimeters. Part 2 of the specific gravity test is to empty the flask of water to approximately 1/3 full. So we want to empty out the majority of the water. We can utilize a pan for this process. Until the flask is just about 1/3 full. We want to add 2 to 3 heaping teaspoons, so large teaspoons of soil, to the flask. The soil we're going to add to the flask is the minus 400 sieve soil. So again, go to that section of your pan where you've got pre-sorted soil, and we want to make sure we get the soil down in there. And this can be a bit of a process to make sure we get it down into the flask, 2 to 3 teaspoons of it. Make sure we clear off any soil that ends up on the outside. And then at this point, using the squeeze bottle, it's a good idea to wash down the soil from the neck of this volumetric flask so that all the soil is down into the bottom. Don't overfill the flask to the point that the water has gone above the calibration line. At this point, we're going to take the flask with the soil washed down inside, and we're going to take it over to a vacuum that's set up here in the lab space. I'm going to get it. Tube. Oh, yes, sorry. Yes, there will be a tube at your station. The tube gets attached to the top, push the stopper down in there, and then you're going to take the tube, the volumetric flask and everything, over to the station off to the side. So a quick connect. You're going to push the quick connect into the vacuum system. Vacuum system will be on and running. At this point, what we're doing is we're removing air from this system. We're de-airing both the soil and the water inside the volumetric flask. To do so properly, this will take somewhere in the neighborhood of 5 to 10 minutes. Either the lab instructor or the lab technician will tell you when your sample is ready to go. To encourage the air to remove from the sample, it's recommended that you tilt it to the side and rock it gently back and forth, occasionally rolling the sample. Do not tilt your volumetric flask so far that water runs up in here. It would then get pulled up into the vacuum and would make a real mess. So continue this process until there's no longer any air bubbles seen inside the sample. Disconnect from the vacuum and bring that on over. And at this point, now what we want to do is add any additional distilled water up to the calibration mark on the volumetric flask. So again, either the squeeze bottle and or the larger bottle, bring it all the way up now to the calibration line. At this point in the process, we want to make sure we're not pulling in additional air and the addition of the water. So we want to make sure you're washing it down the side, not allowing that water to drip down in there and in theory capture more water. If needed, we can use the funnel to fill up the majority of the space, and then use the squeeze bottle to bring it up the rest of the way up the neck to the calibration line. Like before, we want to make sure that the bottom of the meniscus is at the calibration line. And if there's any additional water that's now along the sides above the calibration line, make sure you use a dry paper towel to clean that out. Like before, now we want to record the weight of the sample on the small scale, and we want to record the temperature, again at the center of the ball. Make sure you're in degrees Celsius and make sure that number gets written down. We want to make sure that your 3-quart evaporation pan is empty and dry at this point. If we did place water in there previously, just dump that into the sink and make sure we dry it out. We want to weigh the empty pan on the small scale. And then what we're going to do is we're going to pour the contents of the volumetric flask, that is all the water and all the soil, into this pan. And it's entirely likely that some of the soil may get trapped inside the volumetric flask. At this point, we can continue to use the distilled water to wash down that soil out of the volumetric flask into the 3-quart pan. This may take a little time, but it's critically important that we make sure we get all the soil out of the volumetric flask and into the 3-quart pan. Make sure you continue that process till everything is flushed down into the pan. At this point in the process, it doesn't matter that we're adding additional water, because what we're going to do is we're going to take this pan, and we're going to set it aside, and the lab technician is going to place it in the oven for 24 hours, and we're going to evaporate all that water off anyways. What we're really looking for at this point is what's the dry weight of the soil that remained in the flask. That is the last data item we need. So after we've rinsed all the soil out of that volumetric flask, make sure you take your 3-quart pan, make sure it's numbered and you know which number you're using, and place it off to the side where the lab technician has recommended. That is all the procedures associated with the physical properties of soil lab. Before departing from the lab, ensure that your data sheets are completed. Wash down the desk at your workstation, sweep up the floor adjacent to your workstation, and then check in with the instructor before departing. That's all for lab number 1.